So hopefully you were able to copy notes down from page 1 on page, where'd you guys start yesterday? 7 maybe? 6? For page 6. Hopefully you copied down from page 1. So a method of solving systems of equations. Systems of equation. You can just recycle that if you want, Kaden. By substituting equations within one another. Right? So today we're still looking at that. We're still practicing that. Remember, we're going to solve one equation for x or y. It looks like a lot of these are solved for x already for you. And then we're going to substitute this expression into the other equation and solve for the variable. Then, of course, we're going to take what that answer was and substitute it into the revised equation from step 1 and solve for the other variable. So if we're substituting for x, what x equals, that means we are going to be solving for y today. So in place of x, we're going to be putting in that 4y plus 7. So I'm going to start by rewriting this bottom equation, but in place of my x, I'm putting parentheses here because I have to put in 4y plus 7 in for x. All right, and then I'm going to continue copying down this equation. So these are the type, like you did yesterday, where you're going to distribute, combine like terms, and then solve your 2-step. So you have to distribute your 2 through, so you end up with 8y plus 14 minus 6y equals 12. So in order to help us, we're going to combine our like terms. If we have 2 y terms, we can combine them. So 8 minus 6 gives us 2y, and then we bring down that plus 14, the equals and the 12. And then this hopefully is becoming like second nature to you, solving these 2-step equations. So if I subtract 14 from both sides to get rid of my constant, I have 2y equals negative 2. When I divide by my coefficient, I'm left with y equals negative 1. So looking back at this first equation then, I can find x is equal to 4 times the value of y. So now we know that y is negative 1, where they meet, plus 7. So x equals negative 4 plus 7, x equals 3. So remember, we always want our x value and then our y value when we give our solution. Sorry. Does that make sense? Hopefully. All right, so let's look at these practice on page 11, and it looks like we are going to do a boom deck today. So we're going to, in place of the y, since we know what y equals, we're going to put in this thing here. So we have 3x plus 3, and we're opening our parentheses here. So we can put in x plus 2, You should notice when you're substituting that all of a sudden now you only have one variable in the equation, right? So I can't do anything with this 3x. I'm going to bring it down. I'm going to distribute. 3 times 2 is 6 equals 6. It looks like we're going to have 6x plus 6 equals 6. But when you go to get rid of your constant, you should notice that x is probably going to equal 0, right? Because 0 divided by anything still equals 0. If I know what x equals, I can plug it in for x to figure out y. So y equals 2, and our solution is actually a y-intercept, right? They have the same y-intercept. When x equals 0, that tells us what our y-intercept is. All right, this time we know what x equals, so we're going to plug what x equals in for x. So 2 times this 3y plus 4y equals 10. Then I just have to multiply. I've got 6y plus 4y equals 10. So 10y equals 10. When I divide both sides by the coefficient of y equals 1. So my x is equal to 3 times 1, right? If we look at this equation here. So x equals 3, and this is the point 3, 1. Remember, the solution is the point where these two lines intersect. We're finding it algebraically with substitution. Here, we're going to throw in what y equals for y. This gets a little bit tricky when we've got a negative in front of it, though. So 2x, and then we have this minus here. And then we're going to put in 2x plus 1 equals 3. So we've got to distribute that negative through. And when we do, we have negative 2x minus 1 equals 3. These get canceled out, right? We have negative 1 equals 3. Is this ever true? Remember what we say when we get something that's not true? We say this is no solution. That must mean that these two lines are what? Parallel. Well done. This one, we know what x equals. We don't have to solve any for x or y. We can put in what x equals in for x. So I would say 3, and then in place of that x, I'm going to write negative 2y minus 21. And then I've got to bring over that negative 7y equals 41. All right. Ooh, I've got to multiply here. So 3 times negative 2 is negative 6y. 3 times negative 21 is negative 63. And then I'm bringing down the rest of my equation. I'm only multiplying by what's inside the parentheses. When I combine like terms, I end up with being more negative. So negative 13y minus 63 equals 41. When I go to solve this two-step, I'm going to get rid of the constant by taking the opposite of it from both sides. So I have negative 13y is equal to 104. So I'm thinking like 8. Negative 13, negative 8. Because 8 times 3 would be 24, so it would end in a 4. I would carry the 2. 8 times 1 plus that 2 would be 10. So if y equals negative 8, then what does x equal? So this one's a bit longer. Negative 2 times negative 8 minus 21. So here I have x equals 16 minus 21. So x has to equal negative 5. So this is a negative 5, negative 8. ahead and log into your Chromebooks if you're not already. We're going to go to boomlearning.com. I will eventually throw this link in, but not right this second. This is the substitution method. Let me find that. I don't think I've assigned it. There we go. Let's do that. So assign second, third, fourth, and fifth. So when you log into Boom Learning, it should be there. Oh, let me share screens before I do that. So when you go to boomlearning.com, if we look at second hour assignments, this system's substitution method is what we're looking at. And what's nice is these all have been written out for you to show your work. So number 1 should look just like this. So in place of your y, you have to put your 5x here. So you would rewrite this as 5x equals 2x plus 3, and then you'll solve for x. So I would get rid of my 2x from both sides. 3x equals 3. Divide by 3. So if x equals 1, then y equals 5 times 1, which is 5. So this is the point 1, 5. So if I'm putting this in here, I would put a 1 in for my x value, a 5 for my y value, and then ta-da. All right, and so that's what you're going to do. Remember, when you know what y equals, you're going to substitute it in for y. So here we would have x plus 2 equals 10. So that would give us 2x plus 2 equals 10. If we were subtracting 2 from both sides, we have 2x equals 8. So x has to equal 4, which means y is 4 plus 2, which is 6. So this is the point 4, 6. And I wrote way too huge because I know it's smaller on your screen. So with this one, be sure that once you're putting this in for y here, you're distributing and combining like terms. Here, you're pretty much setting them equal to each other. Don't forget, if you know what x equals, you're substituting in for x, not for y. Here, it looks like you're setting them equal. Here you know what x equals again. It's just written a little backwards. Here you know what y equals. Here you know what x equals. So you're not even solving for x or y in any of these. So you have those. Be sure you finish the pages 8 and 9 from yesterday with the pixel art as well. You have not finished that. And I'll throw this into an assignment so that you can actually turn it in when you're done, so you can mark it as done. All right? Stop sharing and flip this to a video so we can throw that in Google Classroom.